Today's episode is all about tokenization. This is the second episode of this five-course series, and if you haven't watched the previous one, go watch it because it won't make sense. Tokenization is the language of ChatGPT, which we will explain here in this episode. Before processing anything that you say, ChatGPT converts your words, your English letters, right, into numbers. And so, like, for example, even the word letters, ChatGPT, if it hears this, it will convert this into the number, like some random number like 953 or like 640, just like something like this, right? It converts it into different numbers because like I used to think, wow, we can actually process like our letters and understand our letters. It's a genius machine, but no, it can only understand numbers, obviously. So that's how it processes it. First, it converts your what you're saying into numbers. Then I can illustrate this basically. It's called tokenization, as you can see in my little notes tab over here. This is going to be linked, this Notion template is going to be linked below. It's called tokenization. The process of tokenization has like just two steps. It's quite simple, but like there's more complex parts. I'll explain. Step one is just converting. Step one is first understanding what a token is. So you've maybe heard that ChatGPT's like language, or sort of how it speaks, is through tokens, through the use of tokens. Tokens are like sort of words slash subwords slash phrases. So for example, if I say over here, the quick brown fox jumped over the lazy dog, it would break down into, like right here you can see I'm highlighting, the quick brown fox would jump over the lazy dog, and then it would break down into like this list of different words, and then it would convert each word into, and it's jump ed, so like different separated meanings. Like this ed, if you add it to the jump, is going to be in past tense. So these different things have different like numerical associations, which are then going to be converted into like numbers like this, breaking down the inputs into subwords. So yeah, that's the process. Step one is take your sentence, take your little fantastic sentence, and then convert it into sort of like a list of different stuff, and then it's like that. Yeah, it just looks like that, and so on. It does that. That's the first step of tokenization, is breaking it down into tokens. And then the second step, actually I'll keep that beautiful illustration, the second step is converting that into numbers. Step two is converting that into like unique numbers. So like it could be very random like this. So for example, yeah, you're here currently learning how ChatGPT works. This course is unique because no one else teaches this, and that is true. But anyway, right after such breaking down process occurs, we swap it up into numbers. So 857, 116, and it's like just random numbers. That's tokenization in very simple terms. In each and every AI model, these numbers are most probably going to be different for every AI model. These are the numbers. Each and every AI model, as I said, has these numbers unique. Like they're, for example, for ChatGPT, the word hello could be in its system could be like, for example, I don't know, just any number like 996, or and in Bard it could be like 502. It could be really anything. I'll explain exactly why. But yeah, let's get into how this actually happens. How is there a system that can detect words? Like, how can you build a thing that can say, okay, here's a string of stuff that I don't understand entirely, but this AI system, but I, as an AI system, can somehow detect each word and tokenize it and make it into like little tokens over here. So the way this happens is through, wait, let me just illustrate that it converts into a number like 502. Yeah, so the way this happens is through tokenization models, tokenizer models. And these models, basically how they're trained is they have their own neural network. Hopefully you understand the concept of neural networks by now, else it would be incredibly painful to explain to you. But if you don't know, I have it here, an explanation. It's somewhere in here. You can probably find it. It's like a brief explanation of what weights and biases are. So here are the weights, the connections between each and every thing. And by the way, if you haven't watched the previous episode, you should watch this, like the previous episode first before you watch this one, because it's all like in order. the course, right? So yeah, it has its own architecture or neural network, which is inspired by the human brain, etc. Well, they say that it's not inspired by the human brain, but then what else is inspired by? Neurons, etc. Weights are basically like connections between these things that like it's like a probability of a neuron firing. If you can imagine your brain right now with all of its complex neurons and all this stuff, the connection between one neuron to the other, that is the weight in this case. In our tokenizer case, that is the weight. And it's like it's a number that says this will fire at like 0.546 probability. Like it might fire if we get this type of input. The probability of it firing is like 0.56. If we get that type of input, we're going to get 0.7. It changes based on its math with like something called matrix multiplication. If you don't know what that is, you should probably go just quickly check that out. It's just like multiplication basically, but with arrays. Anyway, and then there's biases. There's these little constants that are just applied to each layer for numerical stability. I think I have this somewhere in here, but I'm not sure. Each and every tokenizer is trained. In the beginning of its training, it has random weights and biases, like just random numbers, whatever the hell they could find, just make an array of random numbers for each weight, for each bias. And then over time, over what's called epochs, it gets trained through the use of a data set. So, and then its weights and biases are adjusted in a way so that it could correctly sort of navigate the input through and generate good output rather than just random stuff because it has random numbers. The way it's trained is it has like a sentence given to it, like an actual proper coherent sentence, like this is a fantastic course, this is a fantastic course, and is given billions of those sentences, right? Like GBs upon GBs upon GBs of those sentences, and it's supposed to guess where the specific like word is. It's supposed to look through, and instead of guessing the token to be some nonsensical he, right? If I say like hello, if the sentence starts with hello and then it goes on to say something else, the tokenizer must successfully guess it to be the word to be hello, like the first token to be hello, rather than something like he or like hello and then the beginning of the next word, like for example here, hello the. Yeah, so it's supposed to correctly guess that. If it doesn't, that's the training process. That's the. By the way, we'll get into how ChatGPT gets trained in future episodes. But yeah, in the training process, it has like a loss function which evaluates it through an optimizer. There's partial derivatives, all this complex stuff. It runs through and feeds itself like back, basically back propagation, right? And adjusts all the weights and biases to be less random and sort of adjust to be correct. So there's like a loss function that gives some kind of number that says, okay, you were 0.56 number accurate. So it means like you were 56% accurate, but you were 43% off. And so that optimizer that I told you about looks through and it kind of processes that and adjusts the weights and biases on that entire thing. And that's how it gets trained. It has to correctly guess the sequence. So that's pretty much how it gets trained. And if it doesn't correctly guess, it gets adjusted, so on. And if it's correctly guessing the tokens right, it can do, or it's like another system they have to add to the tokenizer basically, but it can do the numerical conversion, the second step as well. Is basically where you just take each and every single unique token that is ever identified in its entire data set and make sure that it maps it to a sort of number. So this is where like hello can become the number 40 or 40. There can be like the letter A, which can be the number 1. All very different, which is why you may see that like in ChatGPT, right, that they're going to have like hello be. You're not going to see this physically in ChatGPT. It's just like behind the scenes that hello is going to be 543 and for Bard it's going to be 956. So that's that. That's how it maps it to each and every original token. At least with Hugging Face models, if you know what Hugging Face is, you should probably go research what that is. Research what that thing is. Hugging Face is like they offer a bunch of they offer a bunch of models, a bunch of their machine learning models, and like they're just like an ML community and so on. With their tokenizer models that they already give you, that you don't have to build it or anything, they give you.
with their tokenizer models, they basically make something called a JSON file, .json file, where each and every one of your words is like mapped to a number. And so in that JSON file, you might see like a thing like this, right? It's like a bracket open and a big array of a bunch of values. And there you see like the letter A, B, like, I don't know, like 50 or something like that, or like 1 because it's the first letter of the alphabet, so on. There's also such things as special tokens. Like, for example, how does ChatGPT know when to end like a specific sentence, or when it's generating its tokens, how does it know to stop? It has like this sort of emergency, like basically in the system, it's like, okay, we've written enough. I'll explain fully in detail in future episodes, but we've written enough. Let me generate this token, which is the number 30,000, for example, which means, which decodes to not any like letter that like A or whatever the hell, but it's rather end the sequence. And then the program sees, oh, okay, there's end the sequence token in there. Let me just terminate the entire program, stop generating anything, and that's it. Let's just give what we've generated to the user, to you, right? So that's how it works. And yeah, there's an end of sequence token that's a special token. There's also a start of sequence token. Yeah, there's an end of prompt and end of sequence token in ChatGPT. If you want to actually know how it looks like, you can go test this out right now. Open ChatGPT and write this to it. Just write this specifically. End of, actually no, there's no end of prompt, like that. Try doing that right now. It's going to say it's going to say, like, ChatGPT is going to say, is it, bro, I'm sorry. ChatGPT is going to say, wait, you haven't written anything. It looks like you haven't written anything. Could you specify what you want from me? I'm here to assist, so on. Because it actually sees that as like nothing, because the program inside of it deletes that and says, okay, the user is done with their input, except there's nothing else other than this thing. So it just kind of nothing. There's just nothing there. So it's just empty. And then ChatGPT is like, hey, yo, you didn't write anything. Like, why are you so toxic? So on. By the way, that JSON file that I told you about, I have to add this other note, is that like you can load it up and kind of load up the tokenizer model from Hugging Face. Like, for example, you got a model already, a trained one, and you have this JSON file. And so you can do this like line of code, right? It's at least in Hugging Face, not in when you're building a model, but it can be. But anyway, you write like a loaded, or just, you can just write like my tokenizer equals tokenizer dot from file, open bracket, and then the name of your file dot JSON, close bracket, and then that's it. Like, tokenizer comes from the library Hugging Face, so that's that. Or like pre-trained transform, something like that. I'm not completely sure, but I'm sure it comes from Hugging Face. But yeah, that's that. That's the only note that I had to add. And thank you for watching. See you next episode.